Hello, everybody. We'll give people a few more minutes to join and then we'll get started. Okay, we'll go ahead and get started. Can people hear me? I hope.
Yes, we can
Yes,
hear
we
you.
can.
Great. Always good to check the audio works. Thank you. So this is an open working meeting on DETNet queuing and scheduling mechanisms. Let me quickly show the Note Well slide so that we can get that dispensed with. Hang on. Okay, this is an IETF meeting. This is the Note Well slide. Uh, you're expected to understand it because it applies to everything that anyone says or shares in this meeting. All righty. So, uh, clicking around, we want to go back there. So, as I hope I said in the mailing list, since there was so much structure to the last meeting, I'm going to try to this one. My intent is to leave a lot of time for open discussion, as I think we ought to be spending some time figuring out what we would like to do, what it makes sense to do. So this is proposed agenda. Maybe spend the rest of this half hour on process-oriented stuff. Peng has a slide deck showing the update to scaling requirements draft. That would be good to go to. And then beyond that, I did a real quick pass over the evaluation slides that were done for the last interim meeting. I can put up a summary slide and we can discuss from there. We can go back and put up other slides from the prior meeting. Anybody want to bash the agenda? Okay. So consider the agenda bashed. I guess where we are is we've done an initial airing of these. These were the 6 mechanisms for which we were able to get material into the last meeting. I think Jinu has had a draft another mechanism, and he said he wanted to focus on C-score for now, and did not see any participation from Antoine. Don't know what to make of that. Any process-oriented comments, questions, or should we ask Peng to go ahead and talk about the updates to requirements draft?
Yeah, sure. Shall I share screen?
Let me see if, oh gee, hang on. Let's see, the button there. I may get your slides. Yeah, let's try that.
Okay.
Okay, well, no, that's not what I wanted to do. Oh, I got to go there. All right. Hang on. I'll keep clicking here. We'll get slides, I promise.
Okay. Sure. Thank you. So I console
Okay, if I've,
maybe.
all right.
So
Okay, so here's the title slide. Not quite sure if somebody remembers where's the magic button on the here to give Peng control of the slides.
to the requirement draft for 03 version. I also send it to the mailing list before. There's only a little changed. So next slide, please. So it's the proposed change of the technical requirements. Okay, the last one is for the section 4. It's about the data plan requirements. So there's a little change to the title in the section 3. The first one is section 3.1.3, yes, and change the title to provide mechanism not requiring strict time synchronization. And for the 3.4, we changed it to be scalable to the large number of flows and tolerate high utilization of bandwidth. So we have the slides for this section later, so I won't really speak too much about these points. And for the section 3.6, we make it clear to DETNET flows rather than all the network flows. And for the section 3.7, we propose the requirement of latency jitter in the case of complex topology, according to Chen's suggestion. And it also wants to meet the proposal of add a requirement or evaluation method of support tight jitter or sync control loops. And for section 3.8, we just change the third type of flows in the figure to non-periodic lower latency requirements, and change the title to support provisioning of multiple mechanisms. And for the section 4, we add some reference to the controller plan framework draft. So next slide, please. So it's changed over the change of the technical requirements about the titles, about the not requiring strict time synchronization, and add more words of the tolerate high utilization. And the last one supports provisioning of multiple mechanisms. So this slide can be discussed later if needed. So we just go to next slides, please. Okay, so for the requirement 4, we think we might have some problems about this requirement, and this meaning for the tolerate high utilization of bandwidth. So we changed some words to explain what it means, because in the last meeting we may have different ideas on this paragraph or text. So the text now is that in order to guarantee deterministic latency and jitter in this environment, the environment is that the flow, the bandwidth utilization is near to 100% utilization, and it is desirable to provide scalable queuing solutions to improve the bandwidth utilization of currently available TSN or any other standardized method. And we give the examples to reduce the resource space required by the current method. For example, it's based on the QCH or the CQF. The updated method is a type of over provisioning and can be improved with more scalable queuing add-ons. So we think this requirement is to see that based on the existing method, is there any space to reduce resource to be more utilized of the bandwidth. And there are also comments to add some words is that when the large number of flows with different SLA demands is aggregated to a link, it is desirable for the queuing solution to provide multiple levels of the deterministic capabilities and schedule the reasonable reasons to achieve the optimization of network resource utilization. I think this paragraph is to see that to provide different methods or different configuration for the different flows. So also to improve the bandwidth utilization. In my mind, I think that the method proposed, the queuing method proposed now is not intended to solve this problem, but some of them can solve the problem. So I prefer to set this requirement to be optional. And I also want to ask if anyone has comments or problems with proposed text or the proposed added text for this requirement.
Janu, do you want to ask the question you posted to chat?
Yes. I just put a text in the chat. When we say tolerating high utilization, I think it means that we have to guarantee the end-to-end latency, even in the case of the high utilization. You know, improving or optimizing the bandwidth itself or the utilization itself is quite a different problem, and I don't think we are talking about that aspect. That's my understanding. Thank you.
Well, so I think that it is to see even in the environment of a high utilization, and the queuing method also can guarantee the latency.
Yes, yes. For some reason, when I turned on the mic, my voice is delayed. I mean, from turning on the mic, and the voice hearing is quite some delay. Anyway, yes, that's my point. We have to guarantee, even in the case of high utilization. That's what the tolerating means. But the text with the red highlights, for example, the guard band thing can improve the utilization. I don't think that's the point here of tolerating high utilization. Thank you.
Okay, so you mean you have the questions about the instance, right?
Well, I think he's pointing out that there are two goals here. And in fact, the text on the slide sort of reflects two goals. The red text is about improving utilization of the link, whereas the paragraph at the bottom seems to be about high utilization of the link and perhaps high utilization of the link mostly by DetNet flows.
Yes, David is correct. You mean the tolerating the high utilization is one thing, and improving the bandwidth utilization is completely different thing. So we should not confuse between two.
Okay, sure. Maybe Thomas, do you want to explain something on this point?
I think, I had a different point I wanted to make, but on this point, maybe we should simply clarify that the only high utilization we're interested in is high utilization by the DetNet traffic itself, because any other traffic, I think we do well understand that it can simply be in a lower priority, and DetNet traffic can push it aside, best effort traffic, and at worst case, we incur the latency of one still pending packet from that lower priority traffic. So that's not a distinguishing factor between the different mechanisms that we have, right? They all can be set up in the network to push aside best effort traffic. So I don't think we need to dwell on that aspect.
Okay. It sounds like a little bit of text revision would be useful here. Not quite sure what to propose. I'll leave that to the draft authors.
Yeah, I think the problem within the DetNet traffic is what type of utilization for DetNet traffic itself does a mechanism support, because we don't simply can add up the guaranteed bandwidth of the flow to 100% of the links, but we also have to take the bursts into account and what impact they will have for latency. So I think that's a little bit tricky to get right, and maybe we can start with comparing examples to finalize that.
So Torlis, direct question. Take a look at the first two lines in black on the slide, starting with meanwhile. Those look like bandwidth lines. Do they need to be gently adjusted to point out that bursts are also a consideration?
Yeah, I mean, we even when the bursts are as small as a single packet and we have 20,000 of flows, these bursts cannot be ignored, right? So that's kind of implied, but of course it might be helpful to make that more explicit. How exactly to do that with the least amount of text is not clear to me, which is why I was saying that maybe we can circle in on this with running through some examples in the meetings as well.
Okay, so I think the conclusion off of this slide is that some revision is needed to focus on that the high utilization is by DetNet, and to consider flows in addition, sorry, to consider bursts in addition to bandwidth.
Okay, sure.
Sean?
I think the bandwidth utilization is the goal of the DetNet traffic, and this is the important difference between the TDM mechanisms. I think for the use cases used TDM mechanism for, the main requirement is to reduce the cost. So I think it is a goal to optimize the bandwidth utilization. So I suggest to add this requirement. But based on the different requirements between the requirement 3.4 and 3.8, I suggested to add this test to the 3.8 to support the different and multiple queuing mechanisms and multiple levels of deterministic capabilities to optimize the resource utilization. Thanks.
Okay, so Peng and Turles, do you think, and actual draft author, do you think you've heard enough just to figure out and propose new text? We don't need it now, but it does look like some adjustment is needed.
Well, I heard it for up to Quinn, so maybe if she can, Quan, if she can provide some example text, she would suggest that's always, you know, a great help, you know, on the list, and I think we can take it in from there.
Cool.
Okay, I have sent emails last Friday. I will resend it on the mailing list. Thanks.
Mm-hmm.
Great, thanks.
And just one more comment on the notion of optional or not, right? So I think all of the mechanisms that we have pros and cons, and I don't think it is clear right now which use case kind of prefers which one. So I'd hesitate of trying at this point in time to distinguish the requirements by severity. I'd rather think that is something we can take into account in the evaluations, in comparing the evaluations and making judgments about them.
Yeah, I tend to agree that I believe the exercise here that we're looking at is one of engineering trade-offs. The different mechanisms are better or worse at different things, and figuring out what makes sense to take forward based on the strengths and weaknesses of each mechanism. Okay, any other comments on this slide? Okay.
So goes next. Okay, sure. It's the requirement 7, be scalable to a large number of hubs with complex topology. for the jitter and for the routing calculation, maybe in the control plan, and also give explanation of the case that didn't match, that doesn't match the above three cases. So for the latency, it is acceptable when the relationship between the upper bounded of end-to-end delay and hop number is linear, but it's accept is a little strict. It is that only acceptable when the jitter is independent of hop number. Otherwise, it is unacceptable. And for the routing of calculation and the resource scheduling, the and some of the methods can be evaluated directly according to the methods above. So, they may need more other methods to evaluate itself.
Yeah, I think for the third bullet on routing calculation, I might tone down the linear relationship as expected, because I think the real requirement there is that the necessary computations be tractable and implementable, and they might not be strictly linear. Obviously, fully exponential is not going to scale, but I don't think strict linearity is an absolute requirement. Although the language you've got here kind of says linear is a goal, so that's not bad. But I'd like to see some mention of tractability and implementability in that bullet.
So maybe these points or these words to be removed or change the.
I would change it, because I think the real requirement is that it can be done. It can be done in running code that works.
Okay.
Jinu?
Yes, thank you. Regarding the second bullet, the jitter. So I understand that the jitter bound is better to be not a function of the hop count, hop number, but the region you gave is quite, I would say, not very persuasive. You know, the latency can also be very tight. The latency bound can also be tight, as well as the jitter bound. But the latency bound can be a function of hop, but jitter bound cannot be the function of hop at all. I think we have a more concrete reasoning for claiming that. I agree on the second bullet itself, but I think more a concrete reason or explanation, I think. Thank you.
Okay. If you could suggest some text on the list, that would be greatly appreciated. Thank you. Also, with the looking at that jitter bullet, with the incorporation of the raw activities into DETNet, is there more going on there that we ought to be concerned with? I'm thinking, for example, wireless links may be using aggressive FEC that results in some jitter impacts. Turles?
That was one of the points I was making in the evaluation and added as an evaluation point, which is to the extent to which a mechanism supports uh, non-clock synchronicity and delay variation on the link, right? Because those doesn't have to be the single point, right? So the delay variation, I think, in the evaluation of the CSQF, TCQF mechanisms, I added as a separate point to, I think, section 3. And the reasons for delay variation on the link, physical propagation latency variation. And the reasons that I found was, on one hand, the length variation in wired links, and the other one was, of course, all type of different reasons on radio links, right? So one, of course, being a lower layer retransmission, which then, if a packet needed to be retransmitted, caused for that packet to have a longer latency than the packets not be retransmitted, and then also reflections and all other crazy radio causes that make the signal take longer. The extent to which they're really relevant, I think, would best be, gotten from folks who have worked on the raw side.
Such as Pascal.
Yes, thank you. So I concur with what Torles said, but in raw, it can be even worse than just a retry. So what we think in our discussions is probably we will have to constrain the number of retries to ensure that one particular hop cannot exceed a certain jitter. On the other hand, it might be, and that's the role of this new entity that Rho is defining, that the path effectively changes. And when we say path, it's kind of a multipath. It's not a linear thing, right? I mean, your packets, copies of your packet may go along a certain path or along another path, or just pieces of your packets to be reassembled may go over different paths, and those paths may evolve because of radio interferences which show up in a different place, in certain place, and you have to go around it. So yes, there will be jitter. I mean, we could signal or identify, some maximum jitter on some segments of the possible path, and so we could bound the jitter because yes, we'll bound the number of retries, we'll bound the time that we can spend on one particular hop. So we could bound the possible path to get to one point where we can do a TCQF or something like that. But there will be jitter. So there must be enough signaling to figure out which packet that is. That's kind of your discussion in your versions of the cyclic queuing and forwarding. We must be able to identify which window this packet belongs to, because jitter will happen.
Okay, I'd like to do a small separation of concerns here. I think Pascal's discussion, Pascal and Turles' discussion of variable link delay, which of course looks like jitter, I think is completely relevant here. I think the path reroute is out of scope for what we need to get done here, because we're mostly looking at what are we doing in an individual node where the control plane or other mechanism that selects the path through nodes would be at a higher level.
I think what Pascal was pointing to is that, similarly to TSN, we may have DETNET subnets, which by themselves are constructed from multiple, radio links across which there may be rerouting. So it's kind of, to us, a subnet, and the reason for variation in latency across that subnet is within that subnet rerouting or alternative path.
Okay, and if you can model that subnet as a link with bounded variability in the
Yes.
latency, then I think it works. But you really do need to model it as a link as opposed
Yes.
to pulling in the control plane here.
Yeah,
Yes,
of
that
course.
was referring to when saying that, for each of those paths we could, and each of those hops along those paths, we could bound maximum jitter, so we can bound the overall worst case.
Okay. Pascal, do you think, Pascal and Trulis, do you think you could suggest some text on variable link latency that manifests as jitter on the list?
Yes, I can try. I can do that. Yes.
Okay.
So,
All I can ask.
it starts, with row. You can have this situation, and because of that situation, we can bound the individual
Yeah. Just
path
please.
a packet can take. So we can bound from A to B. We can bound the worst latency.
Right. Okay. Yes. And please be careful to avoid dragging in the control plane here.
The control plane is just the cause of a jitter, but we don't need to. Yes, we can
Yes.
just. It's bounded, but if it does, but the bound can be quite high because yes, I mean, for CQF you expect very little overlap between one window and the next, but here you could have like if there really there is a faster route taking place. Yes, there could be confusion between windows which take different path, consecutive windows which take different path.
Okay. Any other comments on this slide? All right, one more.
Okay, this one, it is simple that we just change the third type to periodic and lower latency requirement. So just change the name to make sure it's different from what Doris proposed, but it's just about the name. So also want to ask if anyone has comments on this. Okay, sure. Maybe I need to explain more on this figure. It's just we have three types of the DNet flows. Maybe the first one is industrial tight jitter and has hard latency limit, and also for the industrial flows, there's a hard latency limit, but there's no tight. Applications like cloud gaming or others, XR, it has a lower latency requirement of the DNet, but it also has the requirement for the bounded latency. The text in the so we just
Okay. Not hearing any comments, I guess this is okay.
okay,
Janu?
sure.
Just one comment.
Janu, go
Small
ahead.
When we say lower latency, it means very small value. So I understand that you mean lower requirement, right? Reduced requirement.
Yes. I
think it
think
has
in
to be clarified.
the old version, it is a relatively lower latency requirement.
Yeah, I would
Yes.
like a little more explanation in the main text. Thank you.
Okay, first, thank you.
Peng, when you say lower, are you intending that to be with respect to best effort traffic?
now it's lower requirement than the first two type. I mean,
yes,
the
needs,
latency
okay,
limits is not so hard, yeah.
okay, needs a different word or words, perhaps less tight latency requirements. I'm not sure. Issue?
For the process, it's hard. And
Issue, can you get closer to your mic? You're not coming through.
can you hear me?
Now, yes, that's better.
Okay. So the first two, excuse me. For the first two types, it says the hard latency limit. So my guess is when we use hard, then something like a soft is expected. So the red font says lower latency requirement. Actually, I guess it means the loose latency requirements. So maybe we loose and the strict, or the hard versus soft, something like that. Yeah, that's just a wording thing. Maybe loose and strict is more appropriate here. I don't know.
Or looser. But yes, that sounds like a really good suggestion. Thank you.
Can I make a suggestion? We do have the GitHub, and the GitHub has a nice way to open issues. So could we try to use this on this document as well? I feel that the more, small issues we're bringing up, the easier it is for people who raise them to make sure that the authors for the working group are taking care of them well by, having such a better structured mechanism and hoping that the nodes will all carry that over.
It would be a good idea, although we probably ought to, if we're going to do that, there probably ought to be an email to the list pointing from
Okay.
some of the from one of the authors of the draft, pointing people to the GitHub and how to raise issues, so that there's a connection between the issues being raised and a promise from the authors to use that for text proposals. Okay, anything else on the requirements draft? We've run a little over, but I don't think that's a problem. Okay, Peng, thank you very much. Hope you've taken notes on what we've talked about.
Okay, thank you. And anyone, if you want to propose some text, please remember to send it to the mailing list. And we expected to update the draft before the cutoff. It's about only 20 days.
Yeah, that would be good. And speaking just as an individual here, as I can't claim to channel the working group chairs on this, a discussion in Prague about working group last call on this draft might be appropriate. I mean, sooner or later, we need to declare victory on this, and I think a lot of good changes happened from these meetings. Okay.
Yeah. Okay, thank you.
All right. Okay, so rest of this is sort of discussion around the evaluation. Let me go put up a couple of slides quickly to give some idea of where we are, and then I'll just simply open the floor for whatever people would like to suggest. So first thing is to put up a reminder of what we initially concluded about the TSN mechanisms. These are ones that already exist. And what we basically concluded, and some of these sections have been renumbered, 3.5 and 3.6 have been swapped in the more recent versions of the requirements draft. We basically concluded that the two scalability criteria, a large number of flows and large number of hops with complex technology, were the places where we had visible opportunities to do better. Okay, so having looked at that, let's go have a look at, and this will contain mistakes as I put this slide deck together very quickly over the weekend. Hang on, I want that one, just a minute. I need that. Okay, hang on. There we go, that one. So this was, I simply went over all of the slides that that had been posted for the last meeting and just did a summary. And the good news is here's the first scalable large number of flows. We have multiple mechanisms that said yes, and large number of hops. Multiple mechanisms said yes. And with that, happy to take comments, suggestions. What do we do next? Carlos, go ahead.
So I had an updated evaluation slide of the TSN mechanisms in the slide deck for the CQF and GLBF ones, right? So and that particularly added the negatives on these points, sub points that we're still doing, right? So for example, the lack of supporting clock drift in CQF, which we're solving in TCQF and CSQF, and link propagation variation, which we just discussed, right? So those are the additional main points. I remember there might have been other detailed differences, right? So I don't think I would agree to this initial summary to be what I would feel to be an appropriate final summary for the TSN evaluation. And I guess maybe I need to merge this slide or suggest an update to this slide based on what I had in the slide deck I presented last time.
Okay, well this slide is actually not the TSN slide. Here,
Right.
let me quick go grab.
Right. Okay. So you're already trying to summary. Yeah. Okay.
Right. This is the new mechanisms.
Yeah.
We've definitely got alphabet soup of
this has the
acronyms.
additional, right. I don't think this has the additional points that I was putting in, right? And the
Okay, well,
3, 4. Let me try to
okay.
compare this.
So I think the additional points need to be reflected in the scalability requirements draft.
Well, remember that 341 and 342 were already, from I think Yizhu, when she initially did the TSN evaluations, a split of 3-4, right? So I think it goes either way, right? So there may be some things which really need to be better written in the requirements document, but otherwise it can also be sub bullet points that are taken from existing text.
Don't have a problem with that. I just would like to make sure that what goes up here as evaluation points is matched in some reasonable fashion to the requirements to the requirements draft.
Of course. Yes, I have to go back to that side of yours and see how I would think what may be missing there.
Do you want me to try to find that slide you're referring to from the last meeting?
Yeah, that was the slide deck that I was presenting.
All right, which
Actually,
has, alrighty, has 20 slides in it. Okay.
Yeah, it's very
Here's,
much.
okay, I found the slide. Hang on a minute. I also need to, I need to tell PowerPoint to be nice to me today.
I need to bring up your slides for comparison.
Okay, give me a minute. I will put the template slide up. All right, so what I need to do is drop that, and so I think this was this what you were proposing for the new template slide?
Sorry, give me just a second. Go back to that window. Yeah, so that was it, and then obviously the filling in of that with a different mechanism. And just so let me try to bring up, so compare that with the slide that you had.
I was working off of Isu's template that we'd started using for the TSN.
3132. Yeah, so primarily I was breaking up 3.1 into the subsections. So that's not new text. That's just
Good.
the sub bullet items 1, 2, and 3. So then 3.2 is unchanged. So then I was suggesting to add this propagation jitter that we just discussed in the context of raw, and other links as another sub bullet item to 3.2. 3.3 is unchanged. 3.4.1 and 3.4.2 are unchanged. I think I had some additional thought on the evaluation of the TSN mechanisms there, not quite sure. 3.5, 3.6. Yeah, so they changed the order. 3.7 is unchanged. And then 3.8 was grayed out, and I was interpreting. We were just showing from the draft the different traffic classes that we wanted DETNET to be able to support. And the strictest one was the tight jitter and the industrial traffic that needed tight jitter support. So I was in the same way as Jisoo was doing it for 3.4. I was interpreting that as a requirement from 3.8, requirement number 1. But if we want, if we feel that we should more explicitly put that into text in the requirements document as well, that's fine. But I was using the same freedom as 3.4.1 and 3.4.2 was done previously.
Yeah, well, in 3.4.1 and 3.4.2, there was text in the document. It sounds like we definitely need to make sure that we get single thought propagation jitter in addition to raw, if memory serves, power line networking has some variable link propagation delay based on heat stretching cables.
Yeah, so but that is 3.2.1, so that is clearly a new requirement bullet point, whereas in 3.8, the section does talk about the different type of traffic classes. And it's kind of a question. I mean, the question is how do we formalize the evaluation sheet going forward? Because right now we're doing it a little bit ad hoc with which is fine for the time being, but please propose a process.
So I guess the question sort of hiding in there is whether the folks working on other mechanisms would be comfortable with what's being shown here as the new and improved template for recording how the new mechanisms are doing against requirements. It's another round of slide work.
Man, and we don't have to do it right now, right? I think what we need to do is to get to a point where everybody agrees that we have a complete evaluation sheet.
Yeah, and actually we need to get beyond that, because the real job here is to try to get to some initial, I'm going to say suggestions. I'm not even sure I can do recommendations out of here. Hang on, let me go get what I'm thinking about here. There it is. Some suggestions about which, and it might be multiple, which one or ones of these new mechanisms it makes sense to take forward. Ultimately, that's going to be sorted out in the work group as a whole, but some suggestions out of here, hopefully based on requirements discussion, would be helpful. Zhengdong, go ahead.
Can you hear me?
Yes.
Okay, thank you. I have one question or concern on the evaluation slide and evaluation template slide. There are two new requirements there.
Let me go get that. Hang on. Here we go. Go ahead.
Right. Yeah. 3.2.1. It says new mechanism must or shall support single hop propagation, etc. I'm not so sure about this single hop propagation jitter. Is this single hop propagation jitter meaningful to the end-to-end jitter? I'm not so sure. I mean that certainly our concern is on end-to-end jitter, jitter of DETnet flow, end-to-end flow. So is this per hop jitter or a single hop propagation jitter, is it meaningful to the end-to-end jitter? My opinion is this is not so meaningful, because end-to-end jitter is not the summation of all the per hop jitters along the path. Is simply is not just summation. So yeah, that's my concern. Yeah.
Okay.
Thank you.
Would that requirement be better expressed as tolerate? I mean, there are two examples given of links that have variable propagation delay. One was wireless links that are using FEC or retransmit, and the other is power line links where the propagation delay can vary based on temperature due to cable stretching. So would tolerate be better than support?
I think so. The tolerated is a better word here.
Yeah. And we use tolerate in 342, which isn't so much that this is a feature we like, but something that we need we need to deal with.
Exist before we do anything.
Mm-hmm. And Jungdong, did you want to talk about 381 also?
Yes, 3.81. I'm okay with this for now. But you know, I mean, once text is available, I might have a different opinion. But the for now, it is okay to me. Okay, thank you.
Yeah, and if I recall Ping's last slide correctly, not all DetNet traffic is going to have that tight a control loop.
David?
Janu, go ahead.
Yeah, thank you. Yeah. So there are two new requirements, 3.2.1 and 3.8.1, I think. I think 3.8 is not about the scalability itself. So we are scaling DetNet, and we are considering the requirements for the scaling itself. But 3.8 is about the jitter and jitter itself. So we should support tight jitter, yes. And we should support tight latency as well. But we do not specify that explicitly in this requirement, right? That's because the jitter itself and the latency itself is the two basic requirements of the working group itself, I think. So I think 3.8 is quite unsuitable in the scaling requirements. That's my suggestion. And the 3.2.1, it is about the tolerating the propagation jitter. Yeah, I understand it will be better to support or tolerate the propagation jitter, but I'm not sure it is that important in scaling. For example, propagation delay itself, we should support a large propagation delay. But according to the large propagation delay, the jitter will be increasing. That's something for sure. I'm not so sure why we should repeat the same thing here again. I suggest to merge 3.2.1 into 3.2. I think the current statement is enough. That's my suggestion. Thank you.
Sorry if I may have a Q&A on what you were saying, because I'm not quite clear on that. 3.2 itself does not talk about links propagation jitter, that different packets over the same link experience different latency. That is not covered by 3.2. And we obviously have a lot of links that do not have such propagation jitter. And we also have, I think, all the TSN mechanisms built against the expectation that there is no such propagation jitter. So I think if we were just doing a single point, 3.2, and we're saying no in all the TSN cases on that point because they don't support the propagation jitter well, or at least the CQF and test, right? So obviously ATS would support propagation latency jitter, right? But I think we're not getting a good enough evaluation if we just made it one evaluation criteria as opposed to two, which this slide is proposing.
Yeah. Janu, go ahead.
Yeah, my point is that we can list all the necessary requirements that we have to tolerate, but it can be hundreds of them. So I think the current evaluation platform itself is quite broad and covers almost all the aspects of the scaling. I'm not so comfortable expanding the tablet too much. And That's my
Yeah.
impression. It's
Yeah.
going.
Well, I
just,
think it's
going-
too.
Charles, hang on. Let me get in here, please. I would. One of the things that just happened here is that we've merged the raw efforts into DETNet, and I lean towards adding some explicit text for tolerate single hop propagation jitter, because a lot of the wireless links will exhibit propagation jitter because they can't repeal they can't repeal the laws of physics. The flip side, though, is I don't know about 381, in part because after Torles, you proposed this, we have text that just showed up this meeting. Hang on, let me go find it. I got way too many windows here. I have to make sure I grab the right one. I think it's that one. Let's see. We have text that showed up this meeting that basically said that the tight jitter and sync control loops fall under requirement 7, and that's new text that wasn't available when you put the template when Turles put that template together. So as I said, I would definitely lean towards adding the variable propagation delay on links, primarily because raw has been added to our scope. But it looks like this new text merges the or covers the jitter and sync control loops under 7.
And I think that might be then 371 or something instead of 381. That's fine.
Yeah.
Yeah. No, and with respect to what Ginu was saying in terms of there may be the document that we have mentions a lot of details, right? And I think what we're obviously trying to do is find the smallest subset of the details that allow us to sufficiently distinguish the pro and cons of the different mechanisms, right? And that's why I feel that the 3 to 1, for example, is a crucial distinguisher between, the existing TSN mechanisms and the proposals that we made for DETNet, right?
Yeah.
How we judge the different evaluations in the end, that's a different question. But if our evaluations are not able to highlight the crucial differences, then I think we've done misservice in the process.
I take my thinking runs along a different but probably complementary path, which is that with DETNet now encompassing the wireless links that were formerly in the separate raw effort, I think that's enough of a change that it makes sense to introduce a requirement that has very strong affinity to those links. I'm nervous about the evaluation criteria being a moving target. We've been working with this scalability requirements graph for quite some time, and I don't like moving the goalposts, but I think the addition of the raw efforts is a reason to move at least to add the 3-2-1 goal, and I'd hope to keep it limited to that in the hopes of getting somewhere in the near future.
I don't think we're moving the goalposts on the things that we understand, right? I think the further we're going through the process, the more we may start having a better understanding of specific details. And these bullet points 321 and 381, I've been talking for them for quite a long time already, right? So they're not particularly new. We just have a slow process.
Right, and I don't think 381 is controversial. I think the only thing we're busy having a discussion about it, whether it's 381 or 37 something or other. I do think 321 is new to the scalability requirements draft, and I think it's fully justified because of the raw effort.
Yes.
Okay, Turles and I have been having interesting Socratic dialogue. Anybody else have any useful comments? All right. Jungdong, go ahead.
It's just question. I mean, then text for this new requirement of 3.2.1. Who's gonna prepare the text for this requirement? Is there any proposed text already, or?
Turles, do you want to take a initial attempt at sending text to the list and see where it goes? Or maybe we could nominate Pascal.
I opened an issue on the GitHub, and yeah, it would be great if Pascal could be helping to add the knowledge
you and
from
Pascal, if you and Pascal could conspire perhaps in private email, come up with some initial text that would be good. I'd very much like, if Pascal is comfortable with the text, I'll be much more comfortable that we've got the wireless links that are the motivation here covered.
Okay, then another question is that the text for the next second new requirement, which is 3.8.1, is the text is actually what we've seen from Peng Liu's slide, right?
Yes, and that was
There was the requirement 7 or 8. Yeah.
Yeah, let me go find that. I'm sorry. Let me go find that text. It would be. Hang on. All right. Just a minute. I'm having trouble finding the window I want. It should be that one. Right. I believe the text is going to start from here, and I think I heard some comments that this is going to need some editing to pull this point apart from this point.
Right.
If you or Janu or anybody wanted to propose how to edit this text, edit and revise this text to the list, I think that would be good.
Okay, we will work on that. Okay, thank you.
Okay.
The evaluations that I was presenting last time, there was also for the existing text of section 3.7, a difference in interpretation. So I think the prior evaluations were always saying 3.7 is something we cannot evaluate against the scheduling mechanism itself, because it's not scheduling mechanism related. I was trying to make another argument, and I made that in explanation, and then in, I think, slide 10 of my slide deck, I made that comparison between the TSN and the DETNET mechanisms, in this case, specifically the CQF ones. And the point was that this may be network related, but a lot of aspects for scalability that we have, like the segment routing, traffic steering, are things that we can do, hopefully, in conjunction with all our mechanisms. But TSN cannot do this, right? We cannot simply take a large service provider network, make it a layer 2 TSN domain, and call success, right? So when it comes to comparison of TSN and DETNET, that's a core distinguisher, right? So, and we can also not simply try to say, oh, wait a second, we're going to take a large network domain. Every link, we're doing a separate TSN domain, and then we're doing segment routing for a large-scale network on top of it, right? So 3.7 is really, for me, the core thing that sets TSN aside and says, well, you know, however we do it, we cannot use TSN alone in a large network. We need to do our own.
Just a minute.
Mechanism, even if we derive
slow down, please.
from TSN algorithms.
Turles, slow down, please.
Yep.
Okay, so I understand the point you're making, and I think you've accidentally gotten a couple of things confused. DetNet was originally started based on, I think, the primary observation you're making, which is that layer 3 matters and matters in some of these use cases. I don't think there's any argument about that. I believe that the reason for pulling TSN in here was not to try to say, gee, can we just fall back to layer 2, but rather, if you look at the original DetNet architecture, it is a layer 3 architecture that initially says you could use the TSN scheduling mechanisms in the individual nodes, even if the queues are at layer 3. So I don't think the layer 2 versus layer 3 comparison is apt, but we did find some limitations in those existing TSN scheduling mechanisms. So it isn't about using TSN, it's about using the TSN scheduling mechanisms with DetNet at layer 3.
Except that we do not have actual proposals to do so, right? So we're talking against not really existing drafts.
We don't need proposals to do so. The existing RFCs that say to go do this.
No, I don't think that's true. What the existing RFCs for TSN are doing is that they consider a TSN domain as a subnet, and that's exactly what I was saying isn't scaling, right? You cannot take a large service provider network and consider it a single TSN subnet where only on the edge.
I'm going to agree to disagree with you on that. I believe that the existing RFCs propose the use of the TSN mechanisms at layer 3 with DetNet.
No,
and
that is not true.
I believe that's the baseline to start from, rather than automatically saying that TSN cannot be used in a layer 3 network because it's not layer 3.
No, it's always TSN as a subnet in a DetNet domain. That's what they all do. The different variations.
As I said, I'm going to agree
to
disagree with you on that.
that does not use that model.
I'm going to agree to disagree with you on that for the time being.
Yeah, but then please show me a single RFC, or tell me the number of a single RFC of our DetNet TSN work that is not using TSN purely as a DetNet subnet.
All right, I will make a note to go look for that.
Thanks.
Okay, so I thought I'd go put this slide back up again, see if that engenders any other comments as to what we got to do from here, or is the right next step to go update all of the evaluations of new proposals to pick up at least the new 321, a new template that includes the 321 single hop latency requirement. Sorry, single hop latency variation requirement. Anything else? Any other comments, concerns, questions on anything? Let me go get the agenda back up, Turles. Give me a minute here. I have a hard time picking off these windows with the miniaturized display that cloud detects. Turles, go ahead.
We had what hopefully is a useful discussion on comparing and trying to understand the latency behavior of the different mechanisms, GNU and I particularly. I was just proposing two slides with the example that I was making, and I think in general, I think it would be useful to have a little bit explicit examples of the actual worst case end-to-end latency calculation, and when we need to also the jitter calculation. But I think the more advanced mechanisms seem to have some math, which may be a little bit difficult to grasp unless we get to explicit examples. And I was trying to do that to see if we can get a common understanding of that, because I think at this point in time, GNU is telling me something different from what I'm coming up with. I think this is also what I've been seeing over the decade, all the people struggling, trying to understand RFC 2212, that there is a complete lack of explicit examples of that worst case latency calculation in the IETF, and I think also in other literature that was trying to do. The calculus stuff is a hard thing on those mechanisms. So if you can, David, find the two slides I was proposing and bring them up.
Working on it. Just a minute. Where are we here? I think. That one. Okay. Okay. All right. Hang on, I need to go. Okay, I've got the slides into the materials, but I have to go share them from my desktop because whatever conversion they have to do, that MeetEcho has to do, is not yet done.
Oh, wow.
So,
That's crazy.
Well, no, this is MeetEcho is doing some kind of conversion to show them. Okay. All right. Just a minute. About 3 or 4 more clicks, and we'll be there. All right. All right. This is the slide you wanted to start from, right?
Yeah. So the next slide and is the actual example, and the third slide is the.
There we go.
Right. So what this is showing is a flow under test from source 1 to receiver 1 on the right-hand side, going across 10 routers, which could be a ring. And then on each hop, namely on each router's output interface R1 up to R9, that flow is competing with other flows. And for the sake of simplicity, there is always 100 flows arriving on each of the routers R1 to R9, and they're always going just a single hop before they're leaving the ring again. So on every hop, the flow from source 1 to receiver 1 is competing against 100 other flows. And let's say, for the sake of simplicity, the ring is a gigabit link only. The flows are 1 megabit guaranteed rate, so nowhere close to saturating the gigabit. And the burst size is that each of these packets has 1 packet, and we're not even looking at continuous flow. I was just looking at the worst case of what could happen. And so my argument was that on every, and the links from where the flows are being fed into the router, let's say, have unknown bandwidth, so it could be very fast because each of these flows could arrive on their own incoming interface, right? So these routers can be aggregation routers. So we don't know the bandwidth. So let's say it's unlimited fast bandwidth how they can arrive. And now on every hop I look at it, I can have a queue of 100 packet that just for sake of bad luck arrived at the same time, and my flows packet is behind them. So in my opinion, whatever mechanism I'm using, for the single packet, the worst case latency is really 10 times the latency of being behind 100 other packets, which
Okay.
kind of on the next
Let
slide
me-
I count.
Okay, before we go to the next slide, let me let Janu in, since he's the other major participant in this discussion.
Yeah.
Janu, go ahead.
Okay. Thank you. Yeah. Before into going any further, I'd like to say that the Torres brought up an important issue. I think that the solutions we are suggesting now have all different latency performance. We all have different latency performance. We can guarantee different latency bounds. I think we have to be able to show it with mathematical expression explicitly. Otherwise, all our saying is kind of a void. So currently, I know the latency bound of the ATS and the fail queuing or C-score, but other than that, I'm not aware of the mathematical expression. So I suggest all the authors of the solution come up with the mathematical expression. Then our discussion will be much more fruitful, I think. Thank you.
And I think that's fine. I'm just saying that the formula you showed me, I couldn't map that to my example here. And if I was trying to map it, I couldn't come up with the same results as
Thomas,
from
I'm
that.
kind of, I'm very frustrated. I have been trying to understand you for like 2 or 3 months, but you're still not getting it. So I strongly suggest you to read the papers. It
I
has
did
all the
read the
solution you
I
want
did
to
read the
have.
papers, and I did read the papers, and I'm asking you if you can tell me what in this example the guaranteed latency for the flow is, and when, as I think you're coming up with a lower latency than I was just explaining, how that can be. What is wrong in my thinking about this worst case end-to-end latency as I was just explaining it? Because I think your formula does not arrive at the same worst case end-to-end latency in this case.
Yeah, I think discussing this example will be better suited in the email, because I think people here will be hard understanding the example itself and the detailed parameters and all the equations. You can
I was
try
trying
it
to
now,
make it
but
as simple
I'm
as
not
possible.
sure the 30 minutes will be enough. That's my suggestion.
Yeah, I mean,
Right.
what you're saying is that the way I understand it is that there is only one consideration for the burst, but the example shows that there is a new burst on every hop that I need to take into account, and that I can have to add up the worst case latency of each of these hops independently. That's the argument that I'm making, and I'm not getting, because I had this example for several emails, and I don't think I got a reply from you that's taking that into account.
I think email is probably going to be a better way to do this. I hope the topology is clear. There are certainly an enormous number of flows here. I mean, there are 1,000 flows
Sure.
that are that are showing up and competing for each router-to-router hop.
No, it's only 101 flows on every hop, but it's a new set of 100.
No, Turles. Across source 2 to source 10, you've got nearly
Yes.
1,000 flows.
That's true. Yes. So
Okay.
there's 1,000 flows that are competing with flow number 1. Yes.
Yeah, nearly 1,000. Actually, I think if I do the math, it's 900. But anyhow,
yes, you're right. 901. Yes.
yeah. So Zhendong?
Slide that Tobles prepared. Are there any more slides?
This
If
one
there
was,
are, then maybe
the
we
third
can
slide was
review.
just doing the math that I was trying to explain. And yes,
go-
there's a bug. It's just 9 competing hops, not 10.
go up
Yeah.
there.
Yeah. So it's
Okay.
there is the bug here. It's not 10 hops times 101, but it's 9 hops by 10. Sorry, I was doing it rather quickly.
Okay.
So
Yeah,
that was all.
I will say right now, I don't. I'm pretty sure that the simple summation that was done here, and in particular, the 101 number is almost certainly wrong.
And what's the argument for that?
The argument is consider a strict priority queue.
Mm-hmm.
Don't even look at these fancy mechanisms. Just consider a strict priority queue where the arriving packet that's running horizontally has absolute priority over everything else. If there are 100 packets in the queue, that arriving packet's going to skip ahead of all but one.
No, I mean all the other flows are also DETNET flows, of course.
Don't think it's quite that simple. In particular, as I said, I don't believe. Looking at the computation you've done, I don't believe that number. Is my immediate reaction. And
right, but
when you say all the other flows are DETNET flows, at that point, you're not looking at what was set up in the data plane to make this work.
And I think I did, right? Because the point is, if these packets, these 101 packets, can arrive at the same time, which is what I was predicating, then they have all the same priority in fair queuing, and they're just being processed in order. And that means
so.
they're
Okay, Torles, what is your point here? What do you want to say?
What I'm trying to say is that I'm looking from very concrete and easily without complex math done examples like this one, and then I'm trying to map it to the math that you're providing, for example, for C-score, and I fail.
I will tell you the reason now. The previous example you gave me in the email, the link capacity was 100 gigabps. Okay, and the service rate is 1 gigabps. The link is 100 gig, and the service rate was 1 gig. And now you come up with different numbers here.
Yeah, of course.
That's the reason your calculus is different from mine. That's the only reason.
But your formula didn't change. You didn't give examples with numbers. You just gave
please look at
examples
the
with
email
variables.
again. Please look at the email again. Then you find the error here. please look at the email again.
Yeah, I think this is better. This is better worked out in email. As I said, the right now the number that's bothering me is I think the simple summation of the interference across all the flows is striking me as peculiar.
Well,
Let's work it out in email.
Yeah, and I just think that these type of things, we've already spent so many emails cycles back and forth, and it seems like we're not getting the answers from the other side we're looking for. So I think that, the high-speed communication with audio is actually working better on things like this. But of course, in person would be even better.
Okay, so I'll put up this slide to make sure people have a chance to see it, since I've not had it up for all that long. But this slide is now in the meeting materials, so people will be able to get to it there as well. All right. Any other topics? Okay, so I think we're looking forward to some more discussion on the list of some of the updates to the requirements draft. And with luck, I'll have time to better prepare for our next meeting in about 3 weeks. I hope to be able to put something on the list to suggest how we can start making progress towards some sort of expressing some sort of preference among the mechanisms we're looking at. Any other comments, questions, concerns? Also, a quick general reminder in case folks aren't aware of it. To the extent, if you've got any problems with how these meetings are being run, feel free to go bug me or bug the working group chairs. Janu?
Yeah, I just want to repeat what I have said before. Yeah, explicit mathematical expression for the latency bound. I think everybody has come up with that. That's my suggestion. Thank you.
Yeah, and I think that's a good one, because in particular, whether the jitter gets summed across the hops or not becomes evident when you look at that sort of expression. So I think that's a good suggestion. Okay. Any other comments or questions? All right, I think we're done a little bit early. Thank you all very much for taking the time. Oh, wait a minute, Pascal?
Yes, it's just a comment, David. It's not related to the discussions we had today, but it's related to the fact that row is being folded back into DetNet, and we have that long-standing discussion about the row architecture. So I just wanted to give a status to the group that we have published the version 14 of the row architecture after the IETF meeting, so sometimes mid-August. And it covers the changes that we decided at the IETF on terminology, etc. And there are still a few minor editorials that are not pushed to version 15. They are in GitHub for Greg Mirsky's comments. But apart from that, it's my belief that the raw architecture is ready for publication, so for workgroup last call at least. So just to let you know that I'm asking for this workgroup last call to take place.
Okay. And with that, I think we're done. Thank you all very much.